Hey everyone, welcome back to the Pre-Calculus 20 videos. In this video, we're going to look at Lesson 2 from Chapter 5, which is talking about multiplying and dividing radical expressions. And more specifically in this video, we're going to look at how to write a radical in simplest terms. So to write a fraction that contains a radical in simplest terms, you have to make sure that there are no radicals in the denominator of the fraction. So there can't be any radicals in the bottom of that fraction. So if there were just one term in the denominator, all you have to do is you would simply multiply the top and the bottom of that fraction by that radical. Okay, so it's kind of very similar to trying to keep a fraction equivalent. Like say you had 1/2 and you wanted it to have a denominator of 6. So to keep that fraction equivalent, you'd multiply by the exact same number. So if you multiply the bottom by 3, you have to multiply the top by 3, and then you'd have 3/6. Of course, this fraction here isn't in simplest terms, but it kind of follows along the same idea where we have to keep it equivalent. So let's try out an example. This one here is the first example in terms of talking about the conjugates. So here we're going to simplify the following radical expression. And so the first one that we have here is 5 divided by 2 square root of 3. So this fraction here is not in simplest terms because we have the square root of 3 on the bottom. The 2 is absolutely fine, but the square root of 3 cannot be there. So what you want to do is you want to multiply it by itself. So you want to multiply square root of 3 on the bottom, and what you do to the bottom, you have to do to that top. So you're going to multiply the top, or your numerator, by square root of 3 as well. So what we'd be left with is 5 square root of 3 over, this would be 2 square root of 3 times square root of 3. So now what happens that here you have square root of 3 is multiplying by itself, and that right there is the definition of a squared term. It means that it's multiplying by itself. So we can rewrite this fraction as the square root of 3, and then that itself is squared. And then we know that a square will cancel out your square root. So then you'll be left with 5 square root of 3 over 2. So your square cancels out your square root, and all you're left with is 3 here. So it'll be 2 times 3. And then we can simplify this fraction by multiplying those two numbers on the bottom. And we're left with 5 square root of 3 over 6. One thing that's really important here, say if this had an index of 3 or 4, this would, having a square would not cancel out that radical. So you will have to multiply by the number of times that there are that index number, okay? But this is essentially how you would go about trying to simplify a fraction that contains a radical. So now what happens if there isn't just one term in the denominator of that fraction? So what happens if we had, say, a binomial? So when we are dealing with binomials that contain a square root, we would multiply both the numerator and the denominator by something called your conjugate of the denominator. And essentially all that conjugate is, it's two binomial factors whose product is the difference of two squares. So its product is the difference of two squares. This is something we studied last chapter, in chapter 4. So if you guys remember with the difference of two squares, essentially what happens that if you were trying to factor, say maybe you had an a squared value subtract b squared value, essentially if you were to break that down to its factors, you get a minus b times a plus b. So here it's like we're going to be working backwards. So suppose the denominator of our fraction was a minus b, then you want to multiply it by those values themselves, but change this to a plus sign. So you want to multiply by a plus b, and what would happen is that you would have a difference of squares. So you would square your first term, square your last term, and then divide it with or separate the two numbers with a negative symbol or subtract. So you'd have a squared minus b squared. So one thing that's going to be really awesome about doing this is that if a or b was a radical, squaring it would get rid of it, assuming that the index is 2. So let's try an example with this one, and this is the next example in your notes. So here we're going to simplify the following radical expression. So here we have 5 square root of 3 divided by 4 minus square root of 6. So this one here has a binomial term in the denominator because it has a 4 and then a negative 6 here as the two terms. So what we want to do is we want to multiply by the conjugate, and you want to multiply the top and the bottom of that fraction. So to get that conjugate, you're going to write in brackets, you'll write the first term, you'll write the last term, and then it gets the opposite symbol. So if this is a subtract symbol, this should be a plus sign. And then what you do to the bottom, you're going to do exactly to the top. So you're going to multiply this whole top by 4 plus the square root of 6. So what we get is 5 square root of 3 times 4 plus square root of 6 all over. And according to what we said above, you would get the difference of squares, which means you squared your first term. So you'd have 4 squared. You separate the two terms with a subtract symbol, and then you square your second term. So it should be square root of 6 squared. Then we can simplify both the top and the bottom. So looking at the numerator of that fraction, we can distribute that 5 square root of 3 to both of those terms, or what I like to call shoot my arrows. So we would have 5 square root of 3 times 4. So you would just multiply the two whole numbers. So you have 5 times 4 is 20. And then you're going to rewrite that square root of 3. Plus, then we have 5 square root of 3 times square root of 6. So with that one there, you multiply the radicans, or the numbers inside those that radical symbol, and you just rewrite that whole number. So it'll be 5 square root of 3 times 6 is 18. That there is all divided by. So 4 squared is 16. Subtract. So the square root of 6 squared, that square cancels out the square root and you're left with just 6. Now you might be tempted to leave this numerator as it is, but you first want to make sure that all of your radicals are in simplest terms. So here we have 20 square root of 3. That's in simplest terms because you cannot pull out any numbers from inside the radical symbol. So 20 square root of 3 is fine. But let's check on this 5 square root of 18. So you want to ask yourself, can you change 18 as a product of a perfect square and some other number? And the answer to that is yes, because you can change this to 9 times 2, and 9 is a perfect square. So you have 5 square root of 9 times 2. And then in the next step, we're going to pull out that 9. For right now, we'll simplify the denominator. So 16 minus 6 is simply just 10. So now our next step here is we're going to pull out this 9. And in order to do that, we're going to square root that 9. So we have 20 square root of 3 plus, so it'll be 5 times the square root of 9. So it'll be 5 times 3, which is 15. And then you're left with 2 inside that square root symbol. And that there is all divided by 10. Now here we are not quite done, because what you can notice between all of the whole numbers, between 20, 15, and 10, is that they all have a number in common. So here you can actually break this down, and you can reduce by a common factor. So here we have 20, 15, and 10. Those all have a 5 in common. So what you can do is divide each of those numbers by 5. So what you'd be left with is 20 divided by 5 is 4. We didn't do anything to that square root, so we're going to rewrite that. And then plus 15 divided by 5 is 3. You're left with square root of 2. That's all divided by 5. 10 divided by 5 is just 2. Now, if you want to at this point, you can even take it a step further, where you could break up this fraction into 2 terms. So what we could do is, we could write our first term with the denominator of 2, our second term with the denominator of 2. So we have 4 square root of 3 divided by 2 plus 3 square root of 2 divided by 2. Now, if this hopefully makes a little bit more sense about why we would break this up, we can simplify this 4 divided by 2. Because 4 divided by 2 is just 2. So you're left with 2 square root of 3. And then you can't actually do anything to this second little fraction here. So we're just going to rewrite it as 3 square root of 2 all over 2. With that said, though, I would accept this answer up above here, where you left it as just one fraction, as long as it's in the simplest terms, in terms of all of those terms within that fraction, or this one here would work as well. So that is everything here for this video. So if you guys have any questions, make sure to come see me in class or just text me on Remind 101. And thank you guys so much for watching.